Okay, guys, we're still on worksheet number 1 for section 9.1. We're doing number 20. You see the items and the terms listed in our sequence. And then in red, again, you see our actual answer. Again, using that answer to go backwards is, you can and you should try as you're doing your homework. Okay? All right. Here's the deal. There's not really going to be anything that we're going to rewrite for anything. I'm going to rewrite them just so, maybe I'm going to rewrite, there we go. I'm going to rewrite them just so I have some space to work with them. But if you look at your denominators, if we leave them as is, that's going to be an arithmetic sequence we're just going to add to every single time. Okay, so that's not going to be our big problem this time. What's going to be our big problem this time is our numerator, because if you look at our numerators, really, it's not like you say, oh, they're all multiples of 2 or anything like that. What you can look, and here's the thing, you need to look for things that are either perfect squares or things that are perfect cubes, right? Because if you look at this, each of these numbers, the 1, the 8, 27, 64, and 125, they're all perfect cubes. And again, it's just practice. You're going to be like, Miss P, how should we automatically know that? You shouldn't. Remember, you have to practice these. You have to start thinking about, patterns and what's popping out at you, what's staring you in the face. So if you look at this, 1 is actually 1 cubed. 8 can actually be rewritten as 2 cubed. 27 can actually be rewritten as 3 cubed. We got 4 cubed, and we got 5 cubed. Okay? And so ultimately, every single numerator has an exponent of 3, so that's what's going to be the same. But then if you notice, let's go purple, I think. Yeah. The number is what's different there. We're used to our exponents being different and our numbers being the same. So when we write our term, a sub n equals, okay, if we're looking just at the numerator, 1, 2, 3, 4, 5, remember that's what's changing, and it's just going up by 1 every single time. So you don't really have to do the actual sequence to figure out what it is, and arithmetic sequence to figure out what it is. You can just write an n, because literally that number matches with each term. I have a 1 when I'm doing the a sub 1, the first term. I have a 2 when I'm doing the second term. I have a 3 when I'm doing the third term. 4 for the fourth term. 5 for the fifth term. Okay? And so then ultimately that's n cubed. And then again, you can go back down here into the denominator and you can do, all right, my first term is a 3 plus n minus 1 times a 2, right? And so when I do that algebra, I'll get a 3 plus a 2n minus a 2, okay? And so then I combine my 3 and my negative 2 to get a positive 1, so that's where I'm getting my 2n plus 1. And remember, guys, these are all for n greater than or equal to 1, okay?